Hi and welcome back. Firstly, thank you all for your positive comments, your views and subscriptions and everything else to my initial introduction video. Today I will start in detail on my Tiger Cub special project. This video is going to be much more technical than my initial introduction, but firstly I'm going to cover quickly a couple of topics. I realise this Tiger Cub special is not strictly pre-65. I've got my tri-greaves and my cub that meet that requirement. This project is about pushing the design of the Tiger Cub to make it best suited for trials and making my own frame similar to a Armac or Drayton. As an engineer, I've always enjoyed trying to improve existing designs, fixing faults, etc. Engineers love to play. I ride pre-65 trials purely for fun. I'm not actually particularly good. I will always be somewhere at the lower end of the results list. Certainly won't be taking points or medals off anybody else. I just enjoy riding with good friends, the social side of it, and seeing how the bikes that I've built perform. For me, a good result is me and the bike staying the right way up, not hurting yourself, and just having an enjoyable time. You'll see me modifying existing Cub parts. I avoid modifying parts that are in good condition. These should be left to people faithfully restoring bikes to their original condition. When I need to modify parts, I select parts that are in poor condition or need notable repairs, broken fins, cracked casings, bad previous repairs, etc. Sort of examples: this clutch cover where the springs are almost machined through. Matter of fact, I can see light there. There's cracks here, here, over here, there, and notable damage to the outside. Similarly, this crankcase half that I'm yet to decide whether to use this one or another one. I received it had this bottom lug either removed or knocked off, then very badly welded back on, causing quite a bit of distortion to this face here. So I'm still deciding whether to use this and sort it out or use another one that I may well do. Over 50 years ago, my first competition bike was a Triumph Tiger Cub, used in schoolboy scrambles. Even back then, I was playing about with modifying designs, changing the forks, even modifying the rear suspension to cantilever type with two Girling shocks mounted under the seat. Very similar to that lovely Cheney Cub that I believe Graham Watson often posts on Facebook. So let's look into the detail and get on with this first part of the Tiger Cub special. Thank you. Hi again. With respect to my thoughts about putting the ignition onto the timing side of the engine, I thought I'd put this mock-up together and explain a little bit more about my reasoning. So I've mounted an engine in a frame loop. I've added a few washers to the tune of about 5 or 6 mil to push the engine over to the drive side, which is something you have to do to be able to get the sprocket further enough out to give some chain clearance to a 4-inch trials tar. So with that in mind, have a look at the front view, you can see the engine is well and truly off centre. The amount of overhang on the drive side considerably more than the timing side. Matter of fact, measuring, a quick crude comparison, you've got about 5.75 inches overhang on the drive side, and if you look at the other side, timing side, that's closer to 3 inches. Particularly at the leading edge, where tree stumps and rocks and things like that may be things that you're trying to avoid. So if I can get the ignition over here in the timing side, I don't think I'll have to add a great deal more width here at all, and yet on the timing side you'll be able to reduce this casing to no more than, probably on this front leading edge, 1/2 inch stick out from the joint face. Obviously this is an old style engine. All this work I'd be doing on the later versions, where you've got a central split between the two crankcase halves. So that's my reasoning, and we can have a little bit more look at the detail of what I'm going to do, or the further work I'm going to do to look at how readily this can be achieved. Thank you. Next step. So I want to see how well this will actually fit in there on this inner timing cover. So in order to get an idea exactly where this would have to sit, I'm going to first of all set this half crankcase up on my milling machine and centre over the bore for the crank main shaft there. So once I've got the mill centred over that area and all the dials zeroed and everything else, I can fit and secure this cover and bore a pilot hole that I know is exactly in the right position of the centre of the main shaft. From that pilot hole I can then make a bung or a plug or something that will allow me to position this centrally over the pilot hole and on the same axis basically as the crankshaft. Once I know that, I'll be able to see exactly where this may fit, where it interferes, where it doesn't. Potentially I may or may not use this existing backplate. I may have a little bit more leeway to position things if I don't use this existing backplate. But first of all, let's get a nice controlled size bore in this outer case, and then I can see exactly where that will fit. It might not be the final outer case that I use. It's fairly bashed up here. Someone has drilled and tapped some sort of additional kickstart stop there, but it'll get me started. These inner covers really are fairly easily obtainable. There's plenty around, so I don't really mind messing about with one just to get me started. A quick look at the drive side just to get an idea of how much we're likely to be able to thin down things there. So obviously at the moment the casing is a good couple of inches in depth. You can see from this, obviously ex-trials casing, the sort of abuse that it can get. So what I've done is loosely propped together a drive sprocket and clutch into this crankcase half. And what you can see is, you know, if you have no alternator rotor here and stator in the casing, if I drop a parallel onto the sprocket, you can see the outer face of the sprocket is barely above this surface of the crankcase. So if you allow a little bit of room for a nut on the end of the main shaft here, you should be able to shorten the main shaft well back and have very little casing depth needed to cover the front part of the sprocket and primary drive chain, just getting a slightly deeper once you get to the rear of the casing and the clutch cover. This milling machine is very versatile. The table can tilt in all three axes, which does make it very useful. But one of the downsides of that is if I want to do any really accurate work, I need to use a clock and ensure the table is dead level in all the axes and square to the spindle. So that will be the first thing I do for this job. Things get a bit repetitive here, so I speeded up the video for a few seconds. I'm going to flip this over and locate on the mating surface of this crankcase. So one of the first things I'm going to do is just go over this surface very lightly with an oil stone, see if I can feel any burrs or bruises or whatever else, just to make sure we're not sitting on any high spots. I like using a little oil stone like this. You can immediately feel if you've got any little burrs or high spots, like I'm getting just round this tapped hole here where there's a bit of swelling. I feel that. That's all fairly good. That's pretty good. That's pretty good. A little bit round here. Need to be careful when I sit down because the machining runs out just there. I've got a bit of casting sticking up. That actually isn't too bad at all. You often find these bits and pieces have been knocking about in boxes and you get a lot of little dings and burrs on faces like that. So let's give that a little clean. Don't know how well you can see it, but you can see the little bright patches around a couple of these holes, just where a burr's been lifted off. Right, so I need to get some parallels or something to clear that, and then I can flip it over and look about bolting on here. So that's not a bad position. Let's see where I can get some clamps on that to actually hold things nicely down. I found this clamping arrangement here where I've got one 12mm bolt going through the camshaft hole and this clamp on here. That's pulling these things down nicely. It's relatively light machining I'm going to have to do, so that should be ample clamping. And I just nipped those up and ran round the edges with a 1.5 thou feeler just to make sure everything was sitting down properly, which it is. So now I can get on with centralising over this main shaft bore, zeroing up everything, and then we can get the casing, the timing casing on the top, and bore that pilot bore. Just getting centred over the crankshaft bore now. I'm on 0 over there. I'm on -5 thou there. So if I split the difference, 2.5 thou, re-zero it, round we come, and that is pretty good. That's on 0 there. So if we check now in this direction, we're -1. Over here we're +1. So let's just tweak that a little back to 0. So we're 0 over here and we are 0 there. So let's get everything else nicely on 0. I also do the mechanical dials just in case we lose the DRO. Check where the backlash is. Zero that one. There. Right over here. And just recheck the mechanical. And that's everything nicely centred on 0. Now so we're all set and ready to add that casing. I'm going to centre drill, then drill this about 14mm, then finally put up a boring bar and take this out to a nominal 20mm. Ultimately, if this all works and I continue with it, there'll be an oil seal fitted at this point. So the size I use at the moment isn't too important because a boss and an oil seal will be added. So let's get going. Just slowing the machine down. Going much too fast for a large drill. Now, now fit a boring head. I've checked the hole size, which is pretty good for 14mm, the size of the drill. Got the boring head up and mounted, and have zeroed it with approximately a millimetre of cut on. So that should be in the region of 16mm. So I know I'm going to be nowhere near my final size of 20mm. I'll take a cut, then I'll remeasure the bore with a 3-point micrometer, and then we'll start opening it out from there. Beauty of the digital readouts is I can move off centre, get easy access for measuring, and then move back on. Otherwise it's a bit tight to fit. So that's 15.5. So I'm going to go and take another cut because my bore micrometers, this one starts at 16. So I've put 40 thou on that. So that's nearly 17.5, and let's just see what the bore mic makes of that. When you're doing fine bores, I find you can't really beat 3-point bore mic for accuracy. So that is almost exactly 17.5 millimeters. So that's good. We know exactly where we are. Things get a bit repetitive here, so I speeded up the video for a few seconds. That should give me a couple of thou to tickle out. No, that's gone on size, so we'll leave it there. Brilliant. So now we should have a bore that is directly on the same axis of the crankshaft. So we can go back now and look again at what that does with respect to the placement of the ignition. Now I've got my reference bore. What I can see is I'm going to need to shift everything this way to be able to get that on centre. So my initial thoughts about whether you could use this backplate or not, I'm pretty sure now you won't be able to use that backplate. Once the backplate's removed, hopefully I can get this bit of the laminations up close to the gear shaft boss here, and that'll allow things to come over enough. So what I'll do is I'll just undo these, take the backplate off and see how that looks then. Having taken the backplate off, I can now get an idea of position. It has always been my thoughts to have this open area here up by the camshaft boss, so that wouldn't interfere. And if I move this bit of the laminations close to the gear shaft boss there, I can see that I've got a fighting chance basically of getting this ID concentric with that bore. So I think my next stage will be actually to make a little plug to fit in here and have a large outer diameter just to register on the inside of these laminations. That means then I'll be able to accurately position this in place and then get an idea of what I need to do in terms of bosses and supports to actually hold the laminations in place here. What is quite encouraging is you can actually see that the coil assembly and the laminations really don't protrude out this way much at all. So you know, it means probably I'm going to have to do minimal modifications to this outer cover. So I think let's measure this and let's get on the lathe and make a little plug to register in here, fit this ID so that this can be sat and I can look to see what else I need to do to the housing. We're on the lathe now. I've put a billet in the chuck. I've turned a diameter just so that I can set the DRO to the correct diameter, and I've touched on the front face to 0 on that. So the first bit I'll do is just a rough turn. I won't hit final size yet. The little 20mm spigot about 4mm long to register in the hole we bored into the timing cover. The outer diameter should be the right size now, so let's just check the lambs on it. Yep, that's a nice snug fit, so happy with that. And I will just turn this little 20mm register the right size now. That's the 20mm register done, so let's just see how the casing fits. And yep, just snugly on that register. So that will do for now. So we'll just take that out, lose the larger diameter in the chuck, and then that's ready to play with. Having made my location bung and put it into that 20mm diameter register on the housing, I can now fit my ignition coil assembly and see exactly where it's going to sit within this housing. So that's a nice snug fit onto there. Get that on straight, drop that on, and I can immediately see that's sitting down pretty damn nice and snugly onto the housing. I'm just potentially going to need a little bit of clearance around the gear shaft boss and the camshaft boss, but that's very encouraging. Also, the top surface of the coil here is actually sitting flush or below this gearbox plate, so I know this really is going to have very little interference with the final cover on this side, maybe just in this area here. So that's good. Let's just get this casing back on the mill and put a little bit of clearance on the gear shaft boss and camshaft boss, and then we can move on. As we've established that the laminations are just clashing with this gear shaft boss just here, I've done a few measurements. There's a reasonable amount of material thickness here, so I'm just going to machine a little bit more clearance in this area here. So I've, as we did before, put the crankcase half on the mill, centered up over the main bearings, and set this facing head up to the approximate diameter of the lamination, so I can get this going and start machining a little bit more clearance. And I'm going to take it down at the diameter this is set to, which is about 95mm, to about 8mm off this face here. So let's see how we get on. I'll move you around so I'm not in the way, and let's have a go. To give some clearance for the mounting plate for the ignition coils and laminates, I need to take a bit of material off this camshaft boss here, just to give a bit more room to work with. So I'm just going to do that now. Having done that machining, hopefully you can see the bit of clearance added here and here, which now means this whole assembly can sit down well, and I know I'm going to have room for a new adapter plate to go onto this housing. So the next steps will actually be to add some pads on the housing here, and those will be located to pick up this slot here, and the new adapter plate that I make will sweep round over here, and we'll have a third slotted fixing just in this area here. But what I'm going to do now is park this activity, because I really want to move on now with the crankshaft. But the objective of doing all this was to understand whether this assembly would fit. I understand exactly where it was going to fit, because it affects the design of the output shaft for the crankshaft required here. So now I've captured all the measurements that I need, and I can nip onto the CAD and just draw up this timing side shaft for the crankshaft, and then I'll get on with finishing the crankshaft itself. That concludes this first episode of the Cub Special work. Please continue with your views, your likes, your feedback is all very welcome. I hope I've succeeded in keeping this a little shorter than the previous video, and hope the heavier technical content isn't too detailed. But as I say, I welcome your feedback and look forward to producing the next video. Thanks very much. See you soon. Take care.